Hello and welcome to Calculus 2 here at Cañada College. My name is Lapuz. In this video we'll be doing checkpoint 6.11. This is from section 6.3. It said find the formulas for the Maclaurin polynomials p sub 0, p1, p2, and p3 for f of x is equal to 1 over 1 plus x. And then find the nth Maclaurin polynomial. Write your answer using sigma notation. Okay. So this is a derivative for Taylor series, or this is the formula for Taylor series. Maclaurin's just the same as Taylor's, except a is equal to 0. So we'll need to calculate this and then find derivatives, etc. All right. It looks like we can write this as 1 plus x to the negative first power. That will make our derivatives a little bit easier. Let's see. We have f of 0, which is going to be our first term, to equal to, let's put 0 in there. This is just going to be 1 over 1 plus 0, which is 1. All right, that's pretty straightforward. Now let's find our first derivative, f prime of x. That is going to be a negative 1 and then 1 plus x to the negative 2 power, or negative 1 over 1 plus x quantity squared. All right. Now before we evaluate this, let's go ahead and take more derivatives. And this next one is going to be positive 2, 1 plus x to the negative 3 power, so that's 2 over 1 plus x to the third in the denominator. And then I think we just need to go up to 3, so the third derivative will be a negative 6, 1 plus x to the negative 4 power, so that is going to be a negative 6 over 1 plus x to the negative 4th power. All right, let's evaluate each of these derivatives at 0. So we put 0 in there, we're going to get negative 1 into the first derivative. In the second derivative, we put 0, we're going to get positive 2. And then for the third derivative, we put 0, and we will get negative 6. Okay, so I think we have this information, and we're ready to put this in. So our constant term polynomial is just going to be 1. That's just a p sub 0. If we want p sub 1, we're going to start off with 1, and then we're going to add on the prime, so that's a negative 1 times x to the 0, or x minus 0 to the first power. Okay, so let's just rewrite this as 1 minus x. P2 will be the same thing, and then we're going to add on the second derivative divided by 2, so that's just going to be positive 2 divided by 2 times x squared, x minus 0 squared. Okay, so that's just going to be, well, 1 minus x plus x squared. And then the last one, p sub 3, is going to be 1 minus x plus x squared plus, oh, we get a negative here, negative 6 divided by, and then 3 factorial. But 3 factorial is also 6. Anyways, this is going to be cubed, and so we will end up with 1 minus x minus, or that's next one's plus x squared, and then this one's a minus, and then that's gone, so that's also x cubed. All right. You can kind of see a pattern here, and this time they want us to actually figure out the pattern so we can write this as a series, or we can stop any time at some nth degree polynomial. All right, so let's see. Putting it all together, we could imagine that our next terms, p sub 4, will be the same thing, x squared plus, or 1 minus x plus x squared minus x cubed, and then you would imagine this will change into a plus, and then this would just be an x to the fourth, and then this will probably be a minus and x to the fifth. So it looks like the pattern, let's call this some n. The pattern looks like they all have coefficients of 1 or -1. It's an alternating series. And then the negative sign here matches with the power, -1 to the same power, because when it's odd, it's going to be negative. When it's even, it's positive. So I think we have an idea of what this is going to be. So our p sub n polynomial can be written as a -1 to the nth, or let's call it k, a different index, because we're going to want this to go to the nth power, or to the nth term. And then so this -1, and then x to the same power, to the k power. And k starts with 0, it looks like, because that's the first term. That'd be +1, and then when k is equal to 1, this would be negative x to the first power. When k is equal to 2, this will become positive, and then this will be x to the second power. When k is equal to 3, this would be negative x to the third power, etc. So I think this works out, and this is going to be our series. Okay, I hope that helps. Good luck.